Welcome to Maratha Vidya Prasarak Samajas, KRDRs, BH Commerce and AM Science, KTHM College, Nasik. Myself, Prof.S.S.Demse, working as Associate Professor in Department of Electronic Science. Dear student, we already discussed Chapter 1 subtopics, that is Microcontroller Architectures. Today's video lecture, we are going to discuss interrupts Part 1. So this interrupt is divided into two parts, Part 1 and Part 2. Let us discuss Part 1 first. Savitribai Phule Pune University prescribed the syllabus for Microcontrollers Learnings EL-332. We already finished these subtopics and now we are going to focus on interrupts, that is unit first, microcontroller architecture, interrupts part first. Interrupt means disturbance to the microcontroller. So the pin diagram of 8051, where the pins are related with interrupts in 8051, that we are going to discuss. Pin number P32 and pin number P33 is related with external interrupt INT0 and INT1. Similarly, pin number P34 and pin number P35, they are related with the T0 and T1 timer interrupt. So these are the four pins reserved for interrupt signals in 8051 microcontroller. The block diagram of 8051 microcontroller also consists of an interrupt block, and that is interrupt control. In interrupt control, there are external interrupt pins INT0 and INT1. So these two. Similarly, timer 1 and timer 0, timer interrupt pins, and there is interrupt signals like serial port, this one. So these are the 5 control signals, that is INT0, INT1, these two external interrupt, timer 0, timer 1, timer interrupt, and for serial communication this is the serial port interrupt. So these are the interrupt blocks in 8051 block diagram. Now let us discuss what is interrupt. Interrupt means, interrupt we define as the disturbance to the microcontroller, and when this interrupt occurs, disturbance occurs, microcontroller attend that interrupt. So interrupt during the program execution, if peripheral device needs the service from microcontroller device, will generate the interrupt and then get the service from microcontroller. The microcontroller interrupts in a control can be either hardware or a software. So in this way there is two types of interrupts, hardware interrupts and another one is software interrupt. Now what is hardware interrupt? If the interrupts are generated by the controllers inbuilt devices like timer interrupts, or by the interface devices, they are called as hardware interrupt. It's interface device or internal device, inbuilt device. That types of interrupts get generated by that device, we name it as hardware interrupts. Software interrupt, if the interrupts are generated by the piece of code, they are termed as the software interrupt. So while the program execution, if the interrupt occurs by the program code, then we name it as software interrupt. The next one terms we are going to discuss, maskable interrupt. Maskable can be disabled by programmer or by the processor. So maskable can be enabled or disabled by processor using program. So this is named as maskable interrupt, which is a controllable interrupt. But non-maskable interrupts, non-maskable cannot be disabled by the program. So once this interrupt occurs, then that is microcontroller get interrupted. So for example, reset, failure in power supply, they are non-maskable interrupt. Interrupt methods: whenever any device needs a service, the device notify the microcontroller by sending it an interrupt signal. Upon receiving an interrupt signal, the microcontroller interrupts whenever it is doing and serves the device. The program which is associated with interrupt is called the interrupt service routine, ISR, or interrupt handler. Now what is interrupt service routine? It is a set of instruction when executed providing the service to the interrupted device. For every interrupt, there is fixed location in memory that holds the address of its ISR. The group of memory location set aside to hold the addresses of ISR is called as interrupt vector table, where the address of interrupt service routines are stored. They are named as interrupt vector table. Advantage of interrupts: the microcontroller can serve many devices. Each device can get a service based on priority assigned to it. Priority means importance given by microcontroller to the peripheral device who is attended first. So that is named as the priority of the interrupt. Highest priority and lowest priority. So that is decided by interrupt priority register. The microcontroller can ignore mask a device request. Microcontroller can ignore the device request. 8051 interrupts. The 8051 microcontroller has 6 interrupts. These are as follows. So this is the 8051 microcontroller interrupts. So first one is a reset. Second one is timer. 2 interrupts for the timer, TF0 and TF1. Rollover occurs, then this TF0 for timer 0, TF1 for timer 1. External interrupt, the 2 interrupt for external hardware interrupts, INT0 and INT1. The serial interrupt, serial communication interrupt, TI and RI. So these are the interrupts. Now let us discuss reset interrupt. When reset button we press externally, then this reset interrupt occurs. It is a non-maskable interrupt, means it cannot be avoided when it occurs. Programmer or processor cannot control it. So that is non-maskable. Since no combination of bits in any register can stop or mask the reset action, unlike other interrupts. So other interrupt can be maskable. So these, but this is non-maskable. Reset is actually external switch whenever a high level is applied to reset pin. The 8051 microcontroller enters the reset condition and program will restart the address 000H. 0000H. So that is initial address. This is the hardware circuitry for reset. This reset switch is there. When we press it, 5 volt directly given to RST pin, and your microcontroller 8051 get interrupted and generate the address 0000H, that is initial address, starting address. Next interrupt, external hardware interrupts INT0 and INT1. Now these interrupts get selected by using external interrupt flag IE0/IE1. So this is the flag belongs to interrupt enable register, set by the CPU when high to low edge at INT0/1, INT0 for IE0, INT1 for IE1, and clear by the CPU when interrupt is processed. This flag will be get cleared when microcontroller attend the interrupt. Activation of INT0. How the INT01 activated? This pin is reserved for pin number 32 is reserved for INT0. Now when it is 0, that means ET0 of TCON register is 0, and then level triggering occurs, and this interrupt enable interrupt enable 0 will be activated of TCON register and generate the 0003H interrupt vector address of interrupt service routine. When it is equal to 1, then this is the edge triggering. So this is edge triggering, and at that time this bit will be enabled. When it is enabled, vector address generated, that is address of interrupt vector service. Microcontroller process this ISR to once this get activated INT0. Now, this is INT1. When it is activated, it is similar to INT0. For 0, then level trigger. For 1, then edge trigger. And at that time, interrupt enable 1 of TCON register 3 bits will be get activated. When it is activated, then this vector address generated 0013, and that is the address of interrupt service routine, and microcontroller proceed that interrupt service routine to attend the INT1 interrupt. Timer interrupt TF0 and TF1. TF0 for timer 0, TF1 for timer 1. Timer interrupt is used when we know the time of certain event that occurs on certain time. The 8051 microcontroller, there are two timer interrupts called timer 0, TF0, timer 1, TF1. TF means the timer flag. This timer flag TF is raised when timer rollover, or when TF will be 1 when the timer rollover reach at its programmed value, and microcontroller jumps to the timer's interrupt routine, ISR routine. Without timer with interrupt, we can have to poll the TF and wait until TF is raised. To poll means monitoring the TF for timer 1 and timer 2. Service serial interrupt RI and TI. Serial interrupt RI and TI. So these are the interrupt in serial communication. To use the serial communication with interrupt, we have to set ES and serial interrupt enable bit along with the external access bit E. Whenever a single byte data is sent or received, the serial interrupt signal generated and the RI and TI flag of SCON register goes high for serial data communication, where the TI and or RI flags needs to clear if the interrupt routine that is written for serial interrupt. Now interrupt service routines are the single microcontroller can serve the several devices in two ways. Interrupt service routines. Interrupt methods. An interrupt is an external or internal event that interrupts the microcontroller to inform that a device needs its services. Polling methods. The microcontroller continuously monitoring the status of given device. When the condition is met, it responds to that device. After that, if it moves to and monitor the next device until everyone gets serviced. The microcontroller check all the device in a round robin fashions. Now this is the diagram shows the input output service using interrupt and polling. So in interrupt and in polling, how this microcontroller attended. Let us assume this is a microcontroller. Switch is pressed, then LED will be on. Switch is released, LED will be off. It's when LED on means microcontroller attend the interrupt. It's off, not attending the interrupt. The device 1 and device 2 get controlled by interrupt service, and next device 1 and device 2 get service from polling methods. So when device 1 wants to interrupt the microcontroller using interrupt service method, then he wants service from microcontroller, press this button, enable the signal, microcontroller service or process that interrupt. So this is the method used in interrupts. In polling method, continuous monitoring. So this is a continuous monitoring. Whether this device wants the service, then that types of method we name as polling. And in polling method, the microcontroller is continuously monitoring, continuously engaged. Now this is about your interrupt methods and polling methods, that is input output services. Difference between interrupt and polling. Interrupt, an event that is triggered by the external component other than CPU that alerts the CPU to perform certain action. The activity in polling is the activity of sampling the status of an external device by a client program as a synchronous activity. Interrupt, when an interrupt occurs, the interrupt handler executes or interrupt service routine execute. In polling, the CPU provides the service. Interrupt cannot occur at a time. Interrupt can occur at a time. Polling occurs at regular intervals. Interrupt request line indicates the device needs service, whereas polling command ready to indicates the device needs a service. Interrupt does not waste much CPU cycles. Polling wastes lot of CPU cycles. Interrupt is insufficient when the device interrupts the CPU frequently, whereas polling is insufficient in polling when the CPU rarely finds the request from the device. So these are the difference between these two. Now the interrupt structure. These are the interrupts, that is INT0, INT1, TF0, TF1, RI and TR. These interrupts and the EX0, EX1, ET0, ET1 and ES. So these are the interrupt enable flags. When both are 1 1, then this AND gate will be 1, and then that request will be sent to microcontroller to attend to execute this INT 0. Suppose this INT 1 wants to interrupt the CPU, then this and this both are should be 1 1, then this get enabled, or get select any one input is 1, output will be 1, and then when this E pin is 1, then AND gate will be enabled, this interrupt gets selected here and interrupt the CPU. Similarly for TF0, TF1 and this. So any one of the interrupt wants to interrupt the CPU, device wants to interrupt the CPU for their service, then through this get enabled or selected. At that time, this pin or flag name as an external access, this should be 1, global access. When this is equal to 1, anyone interrupt can interrupt the CPU. But if it is 0, then all these interrupts get disabled, not interrupt the CPU. So this is a global bit. Now once any one of the interrupt the CPU, when CPU executing the main program, what are the different steps taken? That we are going to discuss. When the interrupt occurs, interrupt may be interrupt 0, interrupt 1, TF0, TF1 or serial interrupt. At that time, microcontroller stop their current, complete their current execution, and the program counter register will stored on stack, content of PC, program counter register stored on stack, and enter with new address, that is the interrupt service routine address, and then that interrupt service routine get executed. Last instruction of this is always a return instruction, high return instruction, that is written from interrupt service routine. At that time, microcontroller PC pop the content from stack and enter in main program execution. So this is the attending of interrupt, external interrupt, timer interrupt or serial interrupt using this structure. Thank you. I think you may clear all points related with interrupts. The next part we will discuss in part 2. Thank you. If you have any questions, contact on my mail ID Prof.S.S.Demse57@gmail.com. My WhatsApp number is 9860389302.